Hi everyone, how are you today? Today we'll keep going with Calculus 2 classes with the physics application. We're going to focus today in the work done to empty or to pump spherical tanks. We have two examples, hemispherical tank and the whole sphere, the tank like the whole sphere. Now, before I start, this is the information you need to know. If you have any question, this is the information you need. If you have any questions, this is our phone number. You can text us, and this is our email. You can send us any email for any concern or anything you're willing us to do for you and to help you with. Don't forget to subscribe and like. Please, if you like, don't forget to like, subscribe. Today, Calculus 2 application of integration work in calculus, hemispherical and spherical tank. Also, we have coming soon SAT classes start soon. Don't forget to subscribe and like. Let us minimize this and go to the problem. Last time we did cylindrical. Last time what we did, guys, the cylindrical tank, right? And this is the question we did last time. Today our question is hemispherical tank. You can read the problem. You can read what? The problem, right? Hemispherical tank of radius 2 feet is positioned so that its base is circular. How much work is required to fill the tank with the water through a hole in the base where the water is to fill the tank, right? The weight density of the water is 62.4. I'm going to explain for you how I did this equation. I'm going to go to my board here. I prepared the graph for you. This is the hemispherical tank, this guy. Okay, let us see what we can do with this. What you have to know before we start, circle equation, something you need to know from before. X minus n squared, y minus m squared equal r squared. Where n and m are, both n and m are the center. Now I'm going to take this guy, take it as a group, then rotate it to make the center in the 0, 0. Okay, you see, I can take all this and make it a group. Okay, then I will rotate this guy to right here. Then take it to make it in the 0, 0 center. Okay? To make it in 0, 0 center. Then the equation for this guy, the equation is x, this 0, 0, right? 0, 0. X minus 0 is x squared plus y squared, right? Y squared equal how much? Y squared, okay, equal r squared. Good. Now, look this guy, how we get this equation. The value of x here, 1, 2, 3, 4. This is 4 and 0. And this is r somewhere here. Right? Look, r from here to here is r. Right? And here. Here we have, let me just put here, a line here and a line here. And this point is x and y. X and Y, right? And that means this is Y from here to here, and this X. That means X squared plus Y squared equals 16, which is the same as what? Which is the same as this equation, right? We can find it by doing the Pythagorean theorem, X squared plus Y squared equals 16. And for me, I make X squared as a variable, as R, any variable. In my case, and you can, it's a dummy variable, it's R squared here. You see back to the here. Here. For what equal R squared? Because I need, I'm gonna tell you why. Because always we have to fill. I'm gonna show you what I mean by this. I can't change this to X, you know what I mean? If you want, I can change this to what? X. 2 square, the radius is 2. Okay, 2 square, this comes 2 square. I can change this one if you need to understand it. Okay. Okay. I'm gonna run with this. Okay. Cool. Okay. And here I can make it for you 2 square if you want. R square, 2 square from the radius. From my radius. This is 2 square. That make this equation. Now you know how to make the equation 2 square, which is give you the form. Look, I'm gonna back to this. Then what we need, look here, if you back to this one, while you're filling this tank, while you're filling this tank, let me just back to my page. It's already on. Okay, this is what we're gonna do next. Okay, let me just take this again. Group. I need only that guy to be grouped, any group. I need to control to make the group to be able to control. What I meant to be just back, if you take any point, again, I give you the you know the equation. Now I want to take a point here, right? And this point has, this give you the radius. This give you the, and this give you the y, the x, right? This point y and x and x, and this always 4. This always what 4, right, guys? The radius. Now, as you're filling the tank, both x and y changing because you're gonna have small circles here. All the time. You're gonna have a small circle all the time while you're filling the tank, the circle in the base like this. Then the circle starts small till you fill the whole tank. Then you fill the whole tank. Now that's what I meant. X squared plus y squared equal this 2. There is 2 squared, x squared plus y squared, right? Equal 4. And notice the x is the, look here, the maximum value for x is 2. Right, guys? The maximum value for x is 2. Then x start, look here, decrease, which is x stand for the radius of the small circles. That's what I meant by r. The r I used in the formula there means that this radii for the plural of radius. These radii, you see, the first radius in the base, you have a full r equal to the 2. X equal r equal to the 2. But when you go up, you see, smaller. When you go here, smaller. Then that's what the equation I need. Okay, we're done with this. Let us go to this guy. Then you understand what I mean by this. R here are the radius you want to fill through the tank. Now, the formula you have to remember, the work done, we have to look here. You have I'm sorry, guys. Now, the work done here, we need it. This is the formula you have to memorize. From 0 to the R, to the top of the tank, from 0 to the R, you need to fill. From 0 to where? To R. I'm gonna put the picture here. This is just small picture. If you remember the tank like this, with the small radius here, right? Good. Then you need to fill it from 0, where 0? From here, 0 up to R. R, which is the maximum value for R, is what here? R equal 2. And here, the kind of force we have is the weight of the fluid. The weight of the fluid. The weight of the fluid, you have to remember, weight of the fluid equal rho. Rho stands for density. Weight density, rho stands for the weight density. That will help me for the second problem. The word density, weight density, rho v. dy, because look here, you're going up, you're filling up, right? Y. If you take a small section, you see the y here, small b's, small b's. Then till you fill the whole tank. Good. Okay. Good. Now, force equal the weight, rho v, and the volume equal area of the base times the height. But remember, the area is a function of y, and the height is a function of y. Then the force equal weight, rho, which is the density, weight density v, rho of the y. Okay, now, volume of the fluid of the tank equal A times y. A is the area of the circle, which is pi r squared. Pi r what? Let me just write it for you. Area equal pi r squared. And r is what, guys? From here, from the top, r squared equal 4 minus y squared. Okay. And the height is what? The height is what? Y. Okay. Then area equal 4 r squared. R squared equal 4 minus y squared. AY equal 4. Then work equal rho v. We end up with here rho v, right? And change v to what? AY, right? Change v to be what? AY HY dy. Pi r squared y. But you remember r squared is what equal? R squared r squared equal, right? 4 minus y squared, y. Now multiply 4 times y for y squared, y cubed, then integrate it. The volume 62, pi goes out as a constant. Both these one are constant. Both these guys are, both of them are what? Constant. You can't take them out. And here, and here. Good. Now integrate, your limit will integrate from 0 to the 2. Then from 0, you start from the 2, 2 squared. Look to this, how I apply it. Now, this is for the hemisphere. Let me just stop this video and go to the next video for the spherical tank. Guys, thank you and have a nice day. And don't forget please to subscribe and like our videos. Thank you guys.